All right, good morning. So today, as you remember, we were talking about direct method for solving linear systems. We did a few examples about these methods, and I think we stopped at example okay, 12. All right, so we'll continue from here. So find the line of intersection of the planes for x plus y minus z equals 0. That's the first line given by this equation. Actually here, all right, the second plane is 2x minus y plus 3z equals 4. First, observe that there will be a line of intersection since the normal vectors of the two lines, that is 1, 2, what is it? That one is 4, 1, negative 1. The second one is 2, minus 1, 3, right? And these are, what is it? The normals of this line. So to solve this one, since we need to find the line of intersection of the planes, right, in a three-dimensional space, when two lines intersect each other, actually their intersection will be a line, not a point, because when two lines intersect each other, they intersect at a point for planes, actually it will be a line. If you're talking about solids, their intersection will be a plane. So here we have this matrix then. If we just form their augmented matrix, here we have 4, 1, negative 1, because 4, 1, negative 1, and here we have 0. The second one is 2, negative 1, 3, and 4. So we have to solve this equation. And using that Gauss-Jordan methods, first we have to reduce this to reduced row echelon form. So let me just interchange this first. So here we have 2, negative 1, 3, 4. The second row, all right, in the first row, the second to the second row. So here we have 4, 1, negative 1, 0. Now we need to create 0 here. If I just multiply the first row by negative 2 and add it to the second row, let me just write here. What we are doing here is multiply the first row by negative 2 and add it to the second row, right? So what we have here, 2, negative 1, 3, 4. And here we have negative 2 times 2 is 4 is equal to 0. And negative 2 times negative 1 is 2, 2 plus 1 is 3. And negative 2 times negative 1, negative 2 times 2 plus 4 is equal to 0. It is 2 plus 1 is 3. Negative 2 times 3, negative 6 plus negative 1, that's negative 7. And negative 2 times 4, it's negative 8 plus 0. Here we have negative 8. Okay. So now we need to have 1 here. The next actual step, let me draw a line, do our calculation here. Let me multiply the first line, first row by 1 over 2. That is 1 over 2 times the first line. So what we have here, if you multiply the first row by 1 over 2, here we have 1, that's our pivot. And here we have minus 1 over 2. And here we have 3 over 2. And 1 over 2 times 4, that's equal to 2. And here we have 0. And here multiply by 1 over 3. 1 over 3 times R2. So here we will have 1, negative 7 over 3, and negative 8 over 3. Right? Now I should multiply the second row by 1 over 2 and multiply, add it to the first row. That is 1 over 2 times R2 and add it to the first row. So I want to have 0 here. So here we have 1, here we have 0, here we have 0, here we have 1. And other calculations, we should do this. Okay. 1 over 2 times minus 7 over 3, right? And we should add it 1 over 2. Okay, and we should add it to 1 plus 1.5 plus 1.5. That's equal to 1 over 3. So here we have 1 over 3, and here we have minus 7 over 3. And how about the second one? If you multiply this by 1 over 2, that is minus 4 over 3, minus 4 over 3, and plus 2. That's equal to minus 4 over 3 plus 2. That's equal to 2 over 3. So here we have minus 8 over 3. And here we have, what is it? 2 over 3. Okay. Now, actually, this is the reduced row echelon form of this matrix. Okay. Now we cannot simplify this further. So as you see here, we have 3 variables, right? X, Y, Z. And here we have only 2 lines. Actually, here we will have one, what is it? Independent variable here, free variable. So if you just write the equation here, what we have here, x plus 1 over 3, that is, this one is z, that's equal to 2 over 3. And how about the second row? Here we have y minus 7 over 3, z, that's equal to minus 8 over 3. Okay, now here we have 3. I can choose this z as t or 3t, doesn't matter. Let me just choose actually 3t. I mean z as 3t because it's a free variable, right? If you substitute here, what we have here, then x will be 2 over 3. Okay, minus, here we have 3t, that's equal to t. And how about y? Y will be minus 8 over 3 plus z, 3t. 3 cancel each other. Here we have 7t. And how about z? Z will be 3t. Right? So what will be the equation of the line? That is actually obtained by intersection of these two planes at the time. The equation of the line will be, that is x, y, z, right? That will be, here we have constants, 2 over 3 minus 8 over 3, and here we have 0. Okay, plus t is a common factor here. Take this out. Here we have, okay, that is plus. It's plus. So here we have 1. Here we have the coefficient is 7. Here it is 3. Okay. And as you know, this thing is, what is it? The direction vector, right? And that one is, what is it? Any point actually, because for the in 3-dimensional space, to draw a line, we need 2 pieces of information. Number 1 is a fixed point where it is passing through, right? And another one is we need the direction, in what direction actually it is moving. So that is the equation of the line, which is obtained by intersecting these 2 planes. Another example, let's P, the vector P whose components negative 1, 2, 1, and Q 2, 2, 0, and V negative 1, 1, 0. Determine whether the line x equals P plus TU and x equals Q plus TV intersect. And if so, find the point of intersection. Intersect means okay, so here we have a kind of line here, right? We have another line here. We are assuming that they intersect. So they intersect here. So assume that's here. Okay, so that intersection point is, let's say, it is that x, whose components are, let's say, x sub 0, y sub 0, z sub 0, right? So here, guys, you need to be a bit careful. Here, t is used in this equation, and also t is used in this equation. me just change my color, but it doesn't mean that they are the same things, right? Because this t is, what is it? It's a parameter, but these two lines are independent lines. So we just use any parameter. So when you're writing the equation, so we'll get confused, right? Because t is used here and t is used here. They are represented different things. So we better actually use different parameter for either for this line or for this line. So since at this point, right, this point belongs to both lines, then we will have that thing. That vector, that point will be equal to p plus t times u, or let me use for the first line, I mean that is a parameter, let's just use s. And these are vectors, as you know. And here we have q plus t times v, right? What is x? X is this point, intersection point. So what do we have here then? If you just actually, what is it? Reorganize this, you'll have this thing. Here we have SU, take this to the right hand side, minus TV, and here we have Q minus P, right? What we are trying to find here is, what are these parameters? So that when we just substitute here, actually it gives us that X vector, right? So now if you just substitute the values, what is U? Right, u is given here, 1 to negative 1. So here we have s, here we have u is 1 to negative 1 minus t. And how about, what is it? V, it is negative 1, 1, 0. And q is 2 to 0. So it is 2 to 0 minus, and p, it is negative 1 to 1. Right? I'm just solving system equations here. So now if you simplify this further, what we have to solve here is, as you see, s times 1, it is s, minus t times minus 1, it is plus t. So here we have s plus t equals, here we have 2 minus minus 1, that's equal to 3. Or 2 times s, here we have 2s, minus 1 times t, minus t, equals 2 minus 2, that's equal to 0. S times negative 1, that is negative s, negative t times 0, that's just 0. That is equal to 0 minus 1, that's equal to negative 1. Right. So now from the last equation, as you see, s equals 1. Now if I substitute here, and t is equal to 2. So these are the solutions, right, of this system. So we need to find this x vector. So using this thing either for this or for this, actually they will produce the same thing at these values. We will get the x vector, which is the intersection of, I mean, the end of, actually the terminal point of this x vector is the intersection of these two vectors. So if I just substitute the first one, then we will get here that x is equal to, right, that's equal to x sub 0, y sub 0, z sub 0 equals, if I substitute in the first one, what is p? P equals minus 1 to 1 plus, it is s times u. What is s? S equals 1. So here we have 1 times, and here we have u. What is u? 1, 2, minus 1. 1, 2, minus 1. So which is equal to negative 1 plus 1 is equal to 0. 2 plus 2, that's equal to 4. 1 plus negative 1, that's equal to 0. Okay, so the lines which are given by these two equations, actually they intersect each other, and the intersection point is this 0, 4, 0, or coordinates of the intersection point is 0, 4, 0. Okay. Let's see what we have next. Remark here, in three-dimensional space, it is possible for two lines to intersect in a point to be parallel or to do neither. non-parallel lines that do not intersect are called skew lines. Okay, because in two-dimensional space, as you know that in R2, right? And therefore, if you're talking about two lines, let's say L1 and L2, the first one is they may intersect each other, right? And second one is actually they may be parallel to each other. And third one is, do we have any other case? We don't have. We don't have here. Either they are parallel. If they are not parallel, they intersect each other. How about R3? Actually, we have three different situations. Number one is maybe they intersect each other. And second one is, what is it? Actually, maybe they are parallel, right? And the third one is, I don't know how to draw this. Actually, three-dimensional space is something like this, right? Actually, maybe it is something here. Another one is passing here, but they never intersect each other. They are not parallel. It is somewhere here. Maybe it's on the second floor. This one is on the first floor. Right? They are not parallel, and they never intersect each other. They are just living in different layers of this space. Okay. All right. So if we are saying that, okay, when they intersect each other, we know that's parallel, but the skew lines, you may not actually seen this before. You may not have seen this before. So that is skew line. They are not parallel, but they do not intersect each other. They are called skew lines in three-dimensional space. Okay, guys, here we have another thing that we have to be familiar, that is homogeneous systems. Maybe you might have seen this before. Actually, in math, usually when we talk about homogeneous equations, homogeneous system, that is constant term is equal to 0. That's called homogeneous system. Okay, for one-dimensional space, for example, if you're talking about this equation, ax equals 0, so that is homogeneous equation. How about if you're talking about 2, for example, let's say ax1 plus bx2 is equal to 0, that's also homogeneous equation. And if we have a system and bunch of linear equations and all of these equations constant terms, that is 0, as you see here, 0 and 0, then we call this a homogeneous system. Okay, but here in very compact form, how can you write this one? As you see here, this A sub 1, all the coefficient matrix, if you just denote this by capital A and this unknowns by X, and on the right hand side we have 0 vector. That is how we denote the whole system in a compact form, right? Like for example, let's say here we have 2x plus 3y is equal to 1. Let's say here we have 5x minus 7y is equal to, let's say, 8, right? And soon you will see that actually it's just a product of two matrices. We can write it as we have coefficient matrix. It is 2, 3, and 5 minus 7. And here we have the variables, that is x and y. And on the right-hand side, we have 1 and 8, right? That's just a product of these two matrices here. So this one is, let's say, capital A, coefficient matrix. This one is unknown. That's why it is, I'm not going to use actually, because this dots, you may get confused with dot product. It's not dot product, it's matrix product. So that's equal to, here we have constant term by B. So we can just write it as A times X equals 0. This boldface, because this X is a vector and 0 is a vector. This A is a matrix. Okay, so now we are familiar with homogeneous systems. Okay, let's finish this part of the chapter by this theorem. It says that if this A vertical line is 0, and what is it? This A is a coefficient matrix, right? And you know that this one is augmented vector, that's equal to 0. That's our 0 vector on the right-hand side, constant terms. Is a homogeneous system of m linear equations with n variables. So here we have m equations, right? And n variables, where m is less than m. Then the system has infinitely many solutions. Okay. So some examples before we prove this theorem. For example, let's say if you're talking about a system of two equations. Okay, two equations means here this n is, what is it? Number of variables. It must be greater than m. So it must be at least, there must be 3 variables here. Or if you talk about only one, let's say here we have something like this, 3x plus 5y is equal to 0. And if you remember, actually, when you talk about the system of linear equations, we have three conditions, right? Either the system has one solution, or infinitely many solutions, or no solution. We don't have such case like it has only two solutions or three solutions. If it has more than one solution, that means that it has infinitely many solutions. So if you look at this problem, how many equations we have? Here we have one equation, that is m is equal to 1, right? What is m? M is the number of equations. And how about variables, that is n? How many variables here? X and y. We have two variables here. You see here, n is greater than m in this situation, right? If I ask how many solutions does it have, we know that it has infinitely many solutions. Why? Because number of free variables, right, is equal to what? If you remember from the rank theorem, that's equal to n minus rank of a. And what is rank of A? It is the number of, what is it, non-zero rows in reduced echelon form of the matrix. But here we have only one matrix that's non-zero, so that thing is equal to 1. How about n? N equals 2. That's equal to 2 minus 1. That's equal to 1. Does that means that if you solve the system, we will have one free variable. One free variable means it has infinitely many solutions, because free variable means it can assume any value, right? You see here, when you just solve this, here we have, okay, x will be equal to minus 5 over 3 times y. So if I just denote this y as t, right, then x will be minus 5 over 3t. And how many solutions we have? Infinity. If t equals 1, we have one solution. If t equals 2, we have another solution. If t equals 5, we have another solution. Okay? This theorem is talking about a thing. Now for general case, if we prove this, since the system has at least the zero solution, because all homogeneous system, they have at least one solution. Why? Because all variables are equal to 0. That's the solution. 0 is the solution of all homogeneous system, right? So that means that rank of A, it must be less than or equal to m, right? Why? Because that's our first step. And how many lines here we have? 1, 2, 3, 4. And we are saying that here we have, what is it? M linear equations. Here we have m equations, right? And here we have how many variables? Here we have n variables, right? And if you remember from the definition of rank, what is rank? How did they define this rank? Rank is the number of non-zero rows, right, in the row echelon form of the matrix. So since we have m rows, right, how many rows, how many non-zero rows can we have here? Maximum n. So either it's less than n or is equal to m. That's why rank of n must be less than or equal to m. And by the rank theorem, I can just write here number of free variables, right? That's equal to, what is it? It is n minus rank of A, right? Rank of A, which is equal to, now from here, since this rank of A, right, it is less than or equal to m. So if I just put here m, it will be m will be greater, because now we are subtracting bigger number than n. So this will be what is it? Okay, n minus rank of A, this will be greater than or equal to n minus m, right? Because here, instead of minus rank of A, I just substitute m. Because minus, if you just multiply both sides by -1, we have here minus rank of A is greater than or equal to minus m, right? Just substitute here. So this will be greater than or equal to n minus m. And we know that in the question is saying that n is greater than m, or m is less than m. What does it mean? It means that n minus m is greater than 0. So that means that this system has at least one variable, right? It means this n minus m is the number of free variables. So we have at least one free variable, which means that it has infinitely many solutions, because free variable means that it can assume any value. Okay, so that is the proof of the theorem. And let me stop here. Okay, because now this part finished. After 10 minutes, we will continue the next session. See you after 10 minutes.